and what the possibilities are, different programs or applications that we can create. There's different ways that we can show and simulate and express the technology that goes into our applications, for example. So you may simulate a process that or an algorithm, right? But normally when you create an application, your customer doesn't get to peek behind and see that algorithm, right? So that's actually perfect for artificial intelligence, where there's a huge issue with the lack of transparency with AI models and algorithms. But with a quantum application that a hybrid, for example, that you simulate on a device, you can actually show the user the processes that take place and simulate those processes so that the user gains more insight into the inner workings of that artificial intelligence model and how it comes to its conclusions and its results.
I want to go back a bit. Bits are zeros and ones. So, for like normal reference, and we cannot, as you mentioned, that we cannot replicate that much. But qubit is another layer over a bit. Qubit is another layer over bit, right? So what does qubit enables us? And are quantum computers having a speed in qubits? Because I saw that there are a few quantum computers who are like 5 qubits, seven qubits. They're like small, and it goes. I believe that China and IBM have very large qubit models. So what are their speeds? And let's start by what exactly is a qubit.
So a qubit is just like we talked about, a building block in a method to conduct computation. And essentially the reason why a qubit is so much faster than a bit is because a bit can only process information in 2 dimensions, and a qubit can process information in infinite dimensions. And the best way to discuss this is to think about a path planning problem for a robot. So suppose you have a warehouse robot that wants to get from one side of the warehouse to the other side. And what normally robotics would have that robot do is it would go down each of the aisles and essentially all aspects of the maze until it actually finds the exit point, right, or the endpoint. But with quantum, what it would do is quantum would allow it to analyze all options at once, right? Mm-hmm. And so as a result, the amount of efficiency from energy savings, the amount of processing, that power that is saved is immense. And so that's why you have it where qubits are much more powerful methods of computation or tools of computation than utilizing your bits. But to get to the point of the differentiation between the large numbers of bits, IBM recently, I think yesterday, they just came out with their new quantum computer that has, I think it might have like 1,000, a little over 1,000 qubits. Our organization has created simulated quantum computers that have we've simulated between 1 million qubits and 1 billion qubits. But we've had to utilize models, computational models that are inspired by nature and are biologically inspired, so to say. And so by becoming more in tune and more in line with nature, we've been able to gain computational efficiencies and optimizations and improvements that we wouldn't been able to have gained had we used normal computation.